एवरीवन, आज हम पढ़ने जाएंगे सर्चिंग टेक्निक्स इन एन एरे। स्वागत है आपका मैथ स्टूडियोज की इस वीडियो में। शुरुआत करते हैं विद लीनियर सर्च। लीनियर सर्च इज द मोस्ट सिंपल सर्चिंग टेक्निक। इसमें हम हर एक एलिमेंट को एक एरे के अंदर वन बाय वन विजिट करते हैं। सपोज ये हमारे को एक एरे गिवन है। सपोज इसमें 5 3 6 2 सपोज रैंडम एलिमेंट्स हैं और हमारे को एक की दी गई है 2 सर्च करने के लिए। तो हमारी अप्रोच क्या रहेगी? इसके इंडेक्सेस होंगे 0 1 2 3 बिकॉज इट इज अ जीरो बेस एरे। सो हम स्टार्ट करेंगे अपना यहाँ से 5 को देखने में। इफ 5 इज इक्वल टू 2 हम ब्रेक कर जाएंगे, वरना हम नेक्स्ट पे मूव कर जाएंगे। तो यहाँ पे 5 इज नॉट इक्वल टू ट्रू, हम जाएंगे 3 पे। अगेन 3 इज नॉट इक्वल टू ट्रू, हम जाएंगे 6 पे। Then we'll move to 2 and we'll get the final output as index 3 or maybe as true because we have finally found the element. इसका एल्गो अगर अब हम लिखेंगे तो वो भी बहुत सिंपल होगा। इसमें हम लिखेंगे लीनियर सर्च, फिर हम एक एरे लेंगे और एक की लेंगे। ठीक है, अब हम इसमें i इक्वल्स टू 0 करेंगे जो कि हमारे इंडेक्सेस को डिनोट करेगा। फिर हम एक while लूप लगाएंगे। while I is less than array dot length which is equal to 4 over here, right? इस लूप के अंदर हम लिखेंगे if array of I is double equals to key will return I, otherwise we will just I plus plus which is a unary operator, right? So उसके बाद हम लूप के बाहर आ जाएंगे और यहाँ पर हम रिटर्न कर देंगे -1 which denotes that the element was not found. अब हम इसके कोड पर आ जाते हैं। तो जावा के अंदर हम इसका कोड देखते हैं। पब्लिक क्लास लीनियर सर्च। अब हम इसके अंदर एक फंक्शन बना लेते हैं जिसका नाम हम रखते हैं लीनियर सर्च public static void, let's make it int linear search. Let's use the camel case. We'll accept an integer array and an int key to search from, right? We'll first initialize I equals 0. We'll write a while loop while I is less than array's length. If array of I is double equals to key, will return I, and if the control comes out of the loop, will return -1. So this denotes the failure and this denotes the success. Let's make an sample array. Right. We'll write linear search of ARR. Let's search for 6, right? We get an error which says, so here we forgot a statement where we have to do I plus plus in the situation when the array of I is not equal to key, right? That make it into an infinite loop. So to correct it, we have made the correction. Here we get the 4, which is the index 0 1 2 3 4. Hence we get the element at 4th index. Next we write, if we write 4, we'll get it at 3rd index, right? So let's proceed with the binary search. So let's start with the binary search. This is a special type of searching technique in which we need a sorted array. We won't be searching at any random array, okay? So one point to keep in mind is we need a sorted array, okay? Plus this searching technique searches in log of n complexities, while the linear search, it searches in big O of n. So this is quite an efficient type of algorithm. So let's assume a sorted array. Let's just make it. So here we are, 10, 20, 30, 40. It doesn't matter if it is in ascending order or descending order, but it should be sorted. Let's write the indexes 0, 1, 2, 3. So let's assume the key is to be 20. Now we have to understand it deeply. First, the whole array will be there with 10, 20, 30, and then 40. Will have the low over here, high equals here. Okay, so first we have to do is to assign these two pointers. Okay. Next we have to do is we have to find mid, which will be equals to low plus high divided by 2. Okay. So here the low is 0, the high is 0, 1, 2, 3, right? So the mid will be 0 plus 3 divided by 2. So it is going to be 1.5, but we will take 1. Okay, because 1.5 index does not exist in reality, right? So this will become our mid. Then we will search if this mid element is equal to the key. Yes, it is. So we searched for the 20 key as a key in the first iteration itself, right? So this algorithm is quite an efficient algorithm as compared to linear search, because if we started for linear search, first we would go for 20, this 10, right? Then we'll go for 20. So if we assume a bigger array, right? Let's take 20, 21. Let's make it a discrete one, right? 22, 23, 24, 25, and search for key as 23, or make it 24, right? So in first iteration, low will be here, high will be here. It is equals to 0, 1, 2, 3, 4, 5. So the high is 5, low is 0. The mid will be 0 plus 5 upon 2, which will be equals to 2.5, but not equals to 2, right? So this is our mid. Now we have to check if 22 is equal to 24. No, it is not. Then the condition comes, right? We will check two things: mid, key. If it is equal, if it is less, if it is greater than. The three cases comes. If mid is equals to key, then we'll return, which is not true right now. Then if mid is greater than key, that is 22 is greater than 24. No, it is not. So second case doesn't falls in. Then we'll check if mid is less than key. Yes, it is. Then we'll make it low equals to mid plus 1. Then we will make the next iteration. So Now the low comes to 23. So here is the low, here is the high, and then the thing is, now you can imagine the array becomes half of the original. That's how the binary search works, right? Now, again, the mid will be calculated. Mid is equals to low is at third index, high is at fifth index. We'll check the original array, right? Now 3 plus 5 upon 2, which is equals to 8 by 2 is equals to 4, which is here. And now the mid is equals to key. We'll return. Suppose if the mid was greater than the key, then we would have done high equals to mid. Let's search for the code now. Okay, let's make the same array, right? It was still 25, right? So here is the array. Let's make the key equals to 24. Then we'll call the function bin search of ARR comma key, right? Let's define the function public static void and make it int because we'll return the index. Bin search, we'll have an integer array, an integer key as the argument. Oops, a space. Now we will be doing it with the loop. Now this is possible with the recursion as well, but it makes it complexer. Okay, but it makes it complex for the beginners. So let's focus on the looping one. We'll make it int low equals 0 and high equals to arr dot length, because in the starting it was pointing to here. So let's start. Let's make it int length minus 1, right? Because length will be 1 more than the size, right? So while low is less than high, till then the loop will go. If ARR of mid is equals to key, uh, will return mid. This is the base condition. If now then else if ARR of mid is greater than the key, then we'll make it. If the ARR of mid is less than the key, then we'll make it low equals to mid plus high 1, right? Else में तो एक ही कंडीशन बचती है, right? High equals to mid. So let me check it first in mid. Now we'll make it declared, right? And here we will write mid equals to high plus low divided by 2, right? And in the end a semicolon. So it appears to be good to go, right? So let's run it. So we get it 3, right? So let's run this code.
Can I be your superhero?